In this video, I'm going to show you some examples of how to determine the number of lines of symmetry in a shape. Remember that a line of symmetry is an imaginary line that if you were to fold the shape on that line, both sides of the shape would be congruent. Question number 1 says all the sides of this figure are the same length and all the angles are the same measure. How many lines of symmetry does the figure have? So that's telling us that this is a regular polygon. It is a square. All the angles, all the side lengths are congruent. Anytime you have a regular polygon, you can tell instantly how many lines of symmetry it has because a regular polygon will always have the number of lines of symmetry will be equal to the number of sides that the polygon has. In this case, it has 4 sides, so it has 4 lines of symmetry. And here they are. We can divide the square in half like this. We get 2 congruent rectangles that way and that way. And then we can also do the diagonals like this. So we have 4 lines of symmetry, choice A. Number 2 says all the sides of the figure are the same length and all the angles have the same measure. How many lines of symmetry does the figure have? That's telling us that this is a regular triangle. It is an equilateral acute triangle. So we can split this directly down this direction, and then we can turn the triangle and do the same thing this direction, and then turn it and do the same thing this direction. So it has 3 lines of symmetry. And we knew that, again, without even drawing the lines of symmetry, because it is a regular polygon and it has 3 sides, it will therefore have 3 lines of symmetry. Question 3 says 2 sides of this trapezoid have the same length. Now, just glancing at it, it looks like it's probably this side and this side that are the same length. How many lines of symmetry does the trapezoid have? Well, I don't see any way to do this vertically, because if I split this and try to split this across vertically like this, if I were to do that, I'd end up having a reflection across this line, and that reflection would be something like this. If I were to reflect this yellow half right here, that's what I would get. It would be the green half. And clearly that's not symmetrical. The original shape that I have is not symmetrical that way. The same thing happens if I try to do this horizontally in any way. If I try to split it across this way and then I reflect one of the sides across there, if I reflect this bottom side across, I would get something like this. That would be a reflection of this green part right here. And that's not the shape that I have. So there's no horizontal lines of symmetry either there. And then we just need to check the vertices to see if there are any lines of symmetry when we fold along them. So if I were to fold it like this along these 2 vertices, and then I were to try to reflect this line or this side of the shape across the line of symmetry, I would get something that looks closer to this. Looks more like a kite. It's close. It's fairly close, but it's not quite. We should have a right angle right here because we have a right angle right here, and we don't have that in our original shape. If I try the other diagonal across the other vertices, and then I reflect this side across that potential line of symmetry, I would get a square, and our shape is a trapezoid, not a square. So there are 0 lines of symmetry. Question 4 says how many lines of symmetry does a rectangle have? There's clearly 1 line right here vertically and 1 line right here horizontally. The only question is, are there any diagonally? So if we were to draw a line right there, a line of symmetry right there, and then test it, I'm going to trace over this bottom half, and then I'm going to reflect that bottom half across the line of symmetry. And if I were to reflect that bottom half across the potential line of symmetry, it would look like this, like a kite. Just like in our previous example, this would have to be a right angle here, and this because this was a right angle right there, and that is not the original shape we had. If we were to do the other diagonal, it would look exactly the same thing, except it would be just rotated in the other direction. So how many lines of symmetry does this rectangle have? It only has these blue lines right here. They are the only lines of symmetry, so it has 2 lines of symmetry.